Well, hiya. It's your favorite gloopity doopity doo. Can you guess what we're talking about today? That's right, my failures. Hehe, no, we're not. What I'm actually going to be talking about is my little attempt at making an organic chemistry card game. And by attempt, I mean working super duper hard, only for it to not work how I wanted. Which is fine. I'm fine. I'm in no way salty or frustrated whatsoever. But before we do that, I'd just like to point out, yes, I did draw this little guy myself. And yes, I did draw him specifically for this video. Do we love him, or do we love him? Please say you love him, or I mean, he will cry. But yeah, anyways, shall we start the video? I think we shall. I feel like a good way to start this video is by giving a general overview of what the game is and how it's supposed to be played. So let's do that. The game is called Chain Reaction, Reaction, and it takes place on a giant whiteboard. Or at least it was supposed to, but we'll get back to that later. For now, let's just say it takes place on a big old board, Bob for short. The bob needs to be large because you and your opponent will be splitting it down the middle, and you're going to need a lot of room for all the drawing you're going to be doing. And trust me, it's going to be a lot. So pop them fingers and get mentally prepared. In a typical game, there are 10 rounds. Before the first round, let's call this round 0, both players will roll a 6-sided die, and the number you roll will be the length of your starting alkane chain. After you've drawn your starting alkane chain on the board, you're going to next spin the R group wheel, and you can replace one of your hydrogens on your starting alkane chain with the R group that you landed on. How so? By using magical regioselective radical photochemistry, of course. Yeah, let's go with that. You're probably starting to catch on that I'm not qualified enough to be making something like this, but moving on. Rounds 1 through 10 are all going to be pretty similar to each other in how they work. At the start of each round, you're going to draw from 3 different piles. The first pile is the reaction card pile. We'll talk more about the different types of cards later in this video, so just stick with me. You're going to draw 4 reaction cards and then discard 2, either from what you just drew or from what's already in your hand. In the end, you should only be gaining 2 reaction cards maximum per draw. The reaction cards you discard will be put in your reaction card discard pile. This is important to note as the reaction cards are the only ones that get a proper discard pile. You'll see why in a sec. Also, you can only have 10 reaction cards in your hand at any given time, so if you draw after you have 10, you'll have to discard 4 instead of 2. The next pile is the ingredient card pile. Well, actually, there are 2 ingredient card piles, one for each player, since in total there are 250 ingredient cards, and if they were all in one stack, that thing would topple in no time flat. But from your pile, you're going to draw 4 ingredient cards. And you know what? I'm feeling generous, so just keep all 4. And there is no limit to the number of ingredient cards you can have. And finally, if you don't have a support card, or want to replace the one you already have, draw from the, you guessed it, support card pile. You can only have one support card at a time though, so choose carefully. After you've finished drawing all your cards, you now have 2 options. You can either play one or more reaction cards, or you can choose to not do that. If you choose to play your reaction cards, you will carry out the reactions on the cards on your main molecule, on the bob, on your table, on your floor, on the earth, on the... The points you get from playing your cards will depend on a number of factors, which is annoying, and I don't like it, but I guess I'll explain how it works anyways. Just kidding, pranks. I'll explain how to calculate points later when I explain reaction cards. Okay, but what if you choose the other option? If you don't activate any reaction cards, you are allowed to look through your opponent's discard pile, and if you so choose, you can take one of their discarded reaction cards. And if you so choose not to do that either, you can, oh my god, do one of 3 different things. 1. You can draw again from the reaction card pile, drawing 4 more reaction cards and keeping 2. 2. You can draw again from the ingredient card pile, drawing 4 ingredient cards and keeping all 4. Or 3. You can spin the R group wheel and replace another one of the hydrogens on your main molecule with the R group that you land on. And that, finally, is its first single round. Repeat for a total of 10 rounds, and whoever accumulates the most points wins. Yes, I know that was a lot, so let's just take a second to relax and watch my little guy spin. Okay, we good? Great. Let's move on and break down the 3 different types of cards involved in this game. The 3 types are the reaction type, the ingredient type, and the support type. Let's start with the most complicated type, the reaction type, specifically by looking at one of the most complicated reaction cards. At the top of each reaction card is the number assigned to the reaction, which is mostly just for me in my notes, but anyways. By the number is the name of the reaction that can be performed using the card. There are 160 reaction cards in total, but only 120 unique reactions in this game, as some of them have multiple. Underneath the name of the reaction is a box that contains what I'm calling the main reactants and main products of the reaction. A main reactant has functional groups that can be found on the main molecule. This is vital as one of the criteria for using a reaction card is for at least one of the main reactants to be present on the main molecule. Side note, you probably are noticing a lot of R's and squiggles on these main reactants and main products, and I need to clarify what these mean in this game because of the ambiguity associated with these symbols. In this game, an R will look like one of these three, and some of these make more sense for certain reactions, but if your R group doesn't make sense, that's kinda on me for not specifying on the card. But I mean, hey, the cards are only so big, you know? A squiggle, on the other hand, is anything, including R groups and hydrogens, so long as it doesn't change the functional group specified already on the card into a different functional group. Like for instance, these squiggles by this carbonyl cannot be an OH, OR, or Cl because it changes the carbonyl into a carboxylic acid, ester, or acid chloride, respectively. There is one eensy teensy thing though, and that is, in this game, aldehydes and ketones are both represented by a sole carbonyl with at least one squiggle next door. If one or the other is necessary, it will be specified on the card. Underneath the box, on the left, you will always see R arrow P, and both R and P will be highlighted a certain color to indicate the reactant and product probability risk. What is the reactant and product probability risk, you might be asking? Well, no, you most definitely are asking that because I made those terms up. The reactant probability is the probability that the card used before this one will make a product that is the reactant of this card. The product probability, on the other hand, is the probability that the card used after this one will use the product you made with this card as its reactant. Green is high probability, yellow is medium probability, and orange is low probability. To the right of the R arrow P is the base points, which will be modified by any multipliers found lower on the card and or by the number of points per R group that are substituted out for hydrogen, if applicable. What does that mean? Give me a sec. I'll get there eventually. Please don't rush me, I'm doing my best. Underneath the R arrow P, you will find the ingredients list. What is an ingredient? It is any other chemical component that is required to carry out the reaction. Why do I call them ingredients? I don't know. I just thought it was a cutesy name to give it. It's like in no way a scientific name. Underneath the word ingredients, there is a colored line that, you guessed it, gives the ingredient probability. What is that? It is the probability that you will have the necessary ingredient cards to carry out the reaction. How did I calculate the probability? Poorly. Moving on. The colors that are used for ingredient probability are the same as the colors used for the reactant and product probabilities. I made note of all these probability risks on the cards so that when you decide which cards to keep in your hand, you're at least mildly informed about your decision. Also, I'll mention how ingredients work when I get to ingredient cards later. Wow, I say that a lot. Below the ingredients, you may see a multiplier section. If a reaction has two main reactants, then you can carry out the reaction in two different ways. You can either have main reactant 1 present on the main molecule and add main reactant 2 as an ingredient, or you can have main reactant 2 present on the main molecule and add main reactant 1 as an ingredient. Based on which path you take, you will apply a multiplier to the base points, as some functional groups are more rare than others in this game. Next, let's talk about some squiggles. Around 50 of the 120 reactions have the potential to add at least one R group. For each, you spin the R group wheel. So if a card has the potential to add 5 R groups, like say in reaction number 60, you can spin the R group wheel 5 times and add all the R groups you landed on. This makes these cards pretty overpowered as they increase the probability that you can use other reaction cards significantly. So to counterbalance this, for any squiggle that is added onto the main molecule, you can either choose to add an R group, or you can choose to switch it out for a hydrogen. Depending on how many hydrogens you choose to add instead, you'll get a certain amount of extra points added to your base points. Ultimately, you have to decide whether you need more functional groups present or points. I try to make it so that the points you get from choosing hydrogens instead of R groups was worth it, but honestly, I don't know if I did a good job because I didn't actually playtest the game all the way. Yeah, so let's just pretend I mastered the point system in this regard. Whoa, dude, you're like great at everything you do. Oh, stop it, you're making me blush. At the very bottom of the reaction card, there can be one more thing, which I call the clauses. These are basically things that make the organic reaction more accurate to how they would occur in the real world. Here's a list of all the clauses in the game. I didn't write their explanations though. Sorry. I'll just sip some tea while you skim over them. If fulfilled, clauses allow you to apply another multiplier to your base points. Like for instance, the secondary amine preferred clause means that the reaction prefers to use a secondary amine. So if you use a secondary rather than primary or tertiary amine, you get extra points. I did this so that you know how the reaction is supposed to go without having to force you to remember or actually do it like that. I know that's kind of stupid from an educational standpoint to give the player that freedom when the laws of OChem do not permit such to happen, but sometimes, based on your strategy in the game, you might want to put things in a certain way to carry out later reactions. And yeah, I don't know. While we're on the subject, I guess I would just like to point out how much of organic chemistry is kind of omitted in this game, like temperature, light, tautomerization, hydride and methanide shifts, thermodynamics and kinetics, mechanisms and side reactions, and probably so much more, all basically ignored in this game. It really is sad for me to do that, but I wanted to make the game as simple as possible so that it wouldn't be too much of a headache to play. But I wouldn't say I really succeeded at doing that either, though. It is disappointing, and it is one of the many reasons why I don't feel like this project ended up the way I wanted it to be. But, let's keep the video rolling, shall we? By the way, a reaction card doesn't have to be used only in one spot. Say you use reaction number 1 on 2 different double bonds. Well then, you will get points for both. This is true for all cards except for in the case of reaction number 40, which can only be used to perform one reaction at one spot on the molecule. I mean, if not, could you imagine how unfair that would be? Once you have used the reaction card, you put it in the discard pile, which means yes, it is now up for grabs by your opponent. And that's about all there is to reaction cards. Wait, there's one more thing. You're probably wondering why I named the game Chain Reaction, and there is a reason. The main crux of the game is actually to use multiple reaction cards during the same round. Based on the number of reaction cards you use, a multiplier is put toward the total points you got from the cards. So if you played 5 reaction cards during the round, the total points you got will be multiplied by 5. So it benefits you to wait it out before using your cards for as long as you can so that you can get a good chain reaction multiplier bonus. And I don't know, if you're feeling filled with absolute joy, you can yell chain reaction afterwards or something. Yeah. Finally, we can move on to the second type of card, which is ingredient cards. There are 15 types of ingredient card, and these are what they look like. Ignore the colors of the cards. Again, I just used different colored flashcards to make all the ingredient cards because I thought it would be prettier. The numbers under the cards are the number of each in total in the ingredient card deck. As you can see, some ingredient cards are more rare than others. Wild cards are the most common and can take the place of any ingredient card type. I did this so that ingredients aren't too much of a determining factor on whether or not you could use a reaction card. I just mentioned wild cards, but here's what all those other symbols on the cards represent. All ingredients fall under at least one of these 15 types, but many fall under multiple. In order to play a reaction card, you need all the ingredients present. What this means is that you need at least one of the ingredient card types that is present besides each ingredient. For instance, in reaction number 1, in order to play the reaction card, you need to have either a reducing agent ingredient card, or an implemented ingredient card, and a metal containing ingredient card. Once you have played a reaction card, you can't use the ingredient cards you used again, so just put them to the side. I do need to say something before we move on from ingredient cards. Ingredient lists aren't perfect. The way I made them, and the way I made most of this game, is based on my notes that I took exclusively using Professor Dave Explains videos. Thanks, by the way. This is what I mean by I'm not qualified to be making this type of game. My organic chemistry knowledge is limited to these videos. Oh, and I guess my 4 years in college as a biochemistry major, but who cares about that? It's super embarrassing, but this video is more so about the game and less so about the organic chemistry itself, which is, yeah, let's just carry on to the last card type. The last type of card is the support card. These vary, but overall they will help you carry out reactions or get you more points from reactions depending on how much you base your reaction card decisions around it. Each is named after an important chemist that vaguely hints at what the card lets you do. A good support card can be your way of turning the tides of battle. And that about wraps up the game. A bit complicated at first, but once you've played a few rounds, you'll probably get it eventually, hopefully. So then what's the problem? The problem is that once you've played a few rounds, you're not going to want to keep going. And here's why. The game is too messy. Having to draw on a whiteboard and erase over and over again just gets so annoying because of how dry erase boards work. They're not meant for a game with this much precision, so you're constantly going to be finding yourself erasing too much on accident or not enough on accident. And if your molecule gets too crowded, then you'll have to erase things to rearrange everything. It was so frustrating that I couldn't go on past the fourth round. And that's not the only thing that got on my nerves. Remember how I was mentioning all those multipliers and additional points that you can get? Well, there isn't an easy way out of calculating those points yourself. You have to write them down and use a calculator to find your score, and a lot of the times those calculations look like this. Both of these things make the game unplayable unless you have the patience of a saint. But at that point, you're better off just studying or playing an actual fun card game. So what? Is this the end? Was all those months of work for nothing? Well, I did think of a solution. Only thing is, I'm not capable of carrying it out myself because I lack the technological expertise. Yep, that's right. My solution is making it a video game. This would solve so many problems I have with the game and add opportunities that are just not possible with a regular schmegular card game. For instance, when it comes to modifying your molecule, you could just have a point and click system. When an R group that you landed on at a certain position, point and click at that carbon and boom, it drew it in for you. Want to carry out a reaction card? Point and click where you want the reaction to take place and boom, it draws the product for you. And hey, let's take it a step forward. Whenever you have a reaction card selected, areas on the molecule where you can use the reaction can glow. Like, hey, look over here, you can use that here. And as for calculating points, the game does it for you. I mean, it's a computer. Math is like what they do. And just like that, two of the biggest issues I had with the game are just poof, gone. But that's not all. There's so much more. Because the game's digital, you don't have to worry about losing any cards, shuffling, or having the R group wheel be weighted, which by the way it was. You don't have to worry about spinning the R group wheel multiple times because it can spin multiple wheels at the same time. Maybe you can have different cute background, card, and music themes that you can earn by getting points from winning games. Maybe you can play against organic chemistry students across the world. Maybe you can have a more educational mode that implements questions into the game. Like, say, if you have a chain reaction of 5 and you have to answer 5 organic chemistry questions correctly to get the 5 times multiplier. Or maybe if you want different decks based on your level of organic chemistry knowledge, you can choose between an easy, medium, or hard difficulty deck. The possibilities are endless. But sadly, this is but a dream. A dream I wish one day comes true because I really had high hopes for this game. Which brings me to my last discussion point, why I made this game in the first place. It is well known that organic chemistry is a weed out class. I remember in college, aka like a couple years ago, hearing about so many students struggling with the class, to the point where a lot of them changed their majors. It's just sad thinking about how many potential scientists and medical professionals we lost out on because of this dreaded class. So I thought to myself, maybe if I can make it more fun and simple to learn organic chemistry, students would have an easier time and could graduate with what they intended to graduate with. And thus the idea to make a card game was born. I know that may just be wishful thinking. Maybe this card game had no chance of doing any of that, but I at least wanted to try. And I did. So even though this project was a failure in my eyes, I'm still glad I finished it. And I hope maybe you got something out of watching this video. If not, I'm going to leave you with one more thing. For getting to the end of this video, I'm going to do a little slideshow of all the reaction cards, just in case you want to do something with it yourself. But that's about all when it comes to this video. Thank you so much for watching, and who knows, maybe I'll see you later. Bye!